All right, everybody. Hi, and welcome to Notes Part 3 for our thermochemistry. And today we're going to use some of the things that we've learned and bring it into how we deal with the energy having to do with reactions. In a process called calorimetry, this is how we can determine how much heat is involved with a specific reaction or with combusting food. And this is where we get the idea of calories from food, all right? It's figuring out how much energy is actually stored in that food. A calorimeter is an insulated device used to measure the absorption or the release of heat in a chemical or physical process, all right? Water is very often used in a calorimeter because it is so easy to use and really works well. And if you have a situation where you can have a reaction that can take place in water, you can use that water to figure out exactly how much energy was produced. So let's look at this example. A chemical reaction takes place in 25 milliliters of water at 25 degrees Celsius. Calculate the enthalpy change during this reaction if the highest temperature reached by that water is 32 degrees. Well, you have water here and it's changing temperature, so that's a specific heat problem, which we know how to do. All right. So to figure that out, I told you have 25 mils of water. Remember, the density of water is 1 gram per milliliter. So for water, you can just change that right to grams. It changed there about 7 degrees, and your specific heat of water. So this particular reaction, all right, gave off 732 joules of energy. And that's really, it's a very straightforward example, but that's pretty much how calorimetry works. Using that, all right, we come up with what is known as the delta H, or the enthalpy of reaction. So let's see how we're going to use that. All right, so let's take a look at this reaction here. In this reaction, we're decomposing baking soda, sodium bicarbonate. All right, great. And it turns into sodium carbonate, water, and carbon dioxide. I'm giving you additional information here. I'm telling you the delta H is 129 kilojoules. We've dealt with delta H's before when we've looked at reaction graphs. All right, positive means it's endothermic. Fantastic. Okay. But because I'm giving you this with a balanced equation, you can actually use this energy and the balanced equation to go from mass to energy. So let's look to see what I did here. All right, I'm starting with 25 grams of sodium bicarbonate. I'm going to change those grams to moles. All right, that's the molar mass from the periodic table. 1 mole of sodium bicarbonate is 84 grams. I'm then going, and this is our new step, that's why I put a little star here. I'm then looking at my balanced equation. I have 2 moles of sodium bicarbonate. For every 2 moles of sodium bicarbonate, I needed 129 kilojoules of energy. I can use that conversion factor to go from moles of my substance to the amount of energy, to the kilojoules, and you get about 19.2. All right, go on ahead, please, and try the next one. All right, you can pause the video and do that. All right, how many kilojoules of heat are produced when 55 grams of iron 3 oxide reacts with excess carbon monoxide? So there's my balanced equation. Fantastic. Starting with my 55 grams, changing it to moles using my molar mass, then looking at my balanced equation. I have 1 mole here of iron 3 oxide, and I'm telling you that this is an exothermic reaction that gives off 26.3 kilojoules. So I end up giving 9.05. All right, as my final answer. Now, a lot of people ask, and it's a good question, do you incorporate the negative or the positive in these types of problems? You don't have to, because the question itself, how many kilojoules of heat are produced, that's telling you that heat is being given off. And that's what that negative sign is there for. All right, so don't worry so much about the negative and positives with these problems, because they really do lead you to just giving the correct answer. But do realize by looking at this that a negative, it is an exothermic reaction. All right. In our next, I think that's it. Yep. In your next notes, you are going to be using more of those delta H's, and you're going to be adding those up. So please make sure in that case, you are keeping those negative signs when appropriate. All right. Have a good one.